So in this video, I'll be covering some basics about linked lists. In a future video, I will be doing a full program example of a linked list with an insert, a delete, and a search for a linked list. So why do we need linked lists? Well, if we think about an array, we have a size limitation to it. So it's an array and we set it to a size 10 and we can only have 10 elements in it then. And one of the biggest problems is when you want to insert a value somewhere in the middle of the array, you have to shift all the values up in order to insert the element to its correct spot in the middle of the array. And linked lists solve this problem. So what is a linked list? Well, a linked list links data objects. They point at one another. So what do I mean by this? Well, we create a class with a data and a link. And then we link them with these link objects. And we have a data property and a link property. The link will be of the same type as this object. So this link points to this object. So this link is of type object. So this is an object and this link is also an object within the object. And we'll look what I mean now. Let's move this up. Okay, so a singly linked list. A singly linked list is a linked list in which there is one data item and one link to the next data item in only one direction. The last link is always null because it has nowhere to point to. So let's quickly look at a class definition of this, then you'll see what I mean by these links. So public class node T, type T because it can be any type. So we can have a public T data, so we can have a string, we can have an integer, we can have any data type we want here. Public node. So please note that this is node T, so it's of type node, and this is also node link. And we initialize it with this default constructor, which just refers to this constructor and makes these elements null. This constructor takes in a data element, T data, and also a link, a node link, so you can link it to another item. And we just assign this element, this data value to that one, and we assign this link to the link over there. So then we look at what is a doubly linked list. Well, a doubly linked list would just be a singly linked list with an extra property of pointing back at the element that comes before itself. So if we look at a class definition of that, it's exactly the same, except we're going to have this previous pointer, which points to the one before itself. And we would just assign it appropriately within the constructor. Then we look at a circularly linked list. So what is a circularly linked list? Well, it's a linked list where the tail points back to the head. So this means I have a normal linked list, but instead of this tail or the end value being assigned to null, it instead points back to the head of the list, which makes it circular in nature. So this means that tails.link will be assigned head when you create your linked list. So if you make your head and you have a second element, such as here, then after you created your head, you will have your heads next pointing to tail and your tails next pointing back to head. So let's say I create one element and I put in it, let's say 15, and then obviously I'm going to say heads next, or heads link is head. Then if I insert the next element, so I have 15 and I insert say 20, then I'm going to make heads next, the next element, which would be head.link is tail, and tail.link would then be head.